Hello everyone and welcome to lesson 2 of grade 9 review. So today we're going to be looking at algebra and the next lessons we're actually going to look at solving algebraic equations. But for today we're just going to look more at simplifying algebraic expressions and algebraic equations in terms of collecting like terms or expanding and distributing. And then tomorrow or in the next lesson we will actually solve them. So let's start by just trying to evaluate some different fractions we have here and remembering how do we work with fractions if we're multiplying and dividing or if we're adding and subtracting. So when we are multiplying, we simply multiply top numbers and bottom numbers separately. So what I mean by that is that we're going to do 2 times our -3 for our numerators, or our top, which is -6, and we're going to do 3 times 4 on the bottom, which is 12. And then we need to remember to always reduce. So we're always going to reduce to our lowest terms. So we want to make sure we've reduced that fraction as low as we can. So we have to think about what can we simplify -6/12 by, and hopefully we realize that we can simplify that to -1/2. Okay, if we divide both the numerator and the denominator by 6, we can simplify that down to -1/2. Another way to kind of approach this fraction, I'm just going to write an or up here. Or let's say we had 2/3 times -3/4. We can simplify any terms that can be reduced that are diagonal from each other before we actually do the multiplication. So what I mean by that is we can simplify these 3's, right? Because 3/3 is just 1, but since we have a -3 on the top here, this will become a -1 and 1. And we could simplify our 2 and 4 as if that was its own fraction. So 2 and 4 would simplify to 1 and 2, right? If we divide both of those by 2. So then if we multiply it across, our top numbers 1 times -1 is a -1, and our bottom number is 1 times 2, which is 2. So you still get a -1/2 either way, if you simplify before doing the multiplication or if you multiply and then simplify. Both will work. Okay, so let's take a look at when we have a fraction times a whole number, we need to remember that we need to put that whole number over 1. So we're going to add that denominator of 1. Because if we're putting it as a denominator, we're basically saying that we're doing -2 divided by 1, and that doesn't change the value at all. -2 divided by 1 is still just -2. So we always want to add that denominator, and then we'll just multiply straight across. So -6 times -2 is a +12, and 7 times 1 is just 7. Okay, and then we're going to make sure that we simplify this fraction. So we're going to change it to a mixed number. So 12 divided by 7 is 1, and then you're still going to have 5 remaining, so it's going to be 1 and 5/7. So we want to make sure that we change to a mixed number. All right. And then we're going to take a look at adding and subtracting. So what we have to remember with adding and subtracting is that we need to get a common denominator. So only for adding and subtracting. I'm going to say plus or minus. We want to make sure we get a common denominator. So we'll take a look at this first one. We have 2/3 minus 1/6. So hopefully we can see that the common denominator here is 6. So we need to change this first fraction. So we need to take 2/3 and we need to make that denominator 6. So to do that, we are going to multiply by 2. So whatever we do to the bottom, we have to make sure we do to the top. So if we multiply 2/3 by 2, it's going to change it to 4/6. And we don't need to do anything to that second fraction. It already has a denominator of 6. So now when we're adding and subtracting, all we do is just add or subtract the numerator and leave the denominator alone. So 4 minus 1 is 3. We leave that denominator alone, and we want to make sure we reduce it. So always, always, always reduce. All right, we'll try it again one more time with addition. So this time we have to figure out what our common denominator. It's not going to be 4, it's not going to be 5, it's got to be something bigger. So our lowest common denominator here, hopefully if we kind of think through that, we can see that 20, right? If we check out what our multiples of 4 and 5 are, it's going to be 20. So I'm going to have to multiply this fraction by 5 so that we can get a denominator of 20. And I'm going to have to multiply 3/5 by 4 to get a denominator of 20. So let's start with 1/4. I'm going to multiply my numerator by 5 and my denominator by 5. So we should get 5/20. For 3/5, I'm going to multiply my numerator by 4, it'll be 12, my denominator by 4, so again you'll get 20. So we're going to add our numerators, 17, and we're going to leave our denominators the same. And in this case, we can't reduce. Right? 17 is a prime number, so we can't get any lower than that. Let's take a look now at simplifying by collecting our like terms. So first of all, we have to remember, what does like terms mean? Okay, what does like terms mean? And we would have talked about in grade 9 that like terms is basically any term that have terms that have the same variable, or we're going to call it for now the same letter part. So we're going to take a look and see which terms have the same letter part. In that case, we can actually combine those. Okay, so we have this first expression, we have 4x plus 6y plus 1 minus 2x plus 5. Okay, so if I look here, I have 4x. If I look across the rest of my expression, I have to see, are there any other terms that have a letter part that has an x in it? Yes, in fact, right here I have this minus 2x. Okay, so those are like terms. All right, if I look at some others, I have a 6y here. So I'm going to put 2 lines under that just so if I highlight something else, you'll see that that's a like term. I don't have any other y terms, so that kind of stands on its own. And then finally I have this plus 1. So even plus 1, that has no letter part. So now I'm looking, are there any other terms that have no letter part? Because that would be a like term. And we can see that the plus 5 also has no letter part to it. So now when we write these, we're going to try to add them in kind of alphabetical order with the constant or that number part being all by itself. So I'm going to start with my 4x minus 2x. Those are my x parts. And I'm just going to put an equal sign at the front of this. And then I'm going to put my y term. Like I said, there was no other y terms. And then finally, I'm going to put my constants or my numbers at the end of this expression. And now we can actually take a look at simplifying. So we have this 4x minus 2x. We can simplify that. Okay, 4x minus 2x. I like to say, think about apples. If we have 4 apples and we take away 2 apples, we're going to have just 2 apples or 2x. We don't have to do anything with our 6y because we're not combining it with anything. And then finally, we can add that positive 1 and that positive 5. So we're going to have a plus 6. And I just want to remember, I already mentioned it, but when we simplify an expression or we simplify an equation, it's always best to organize your expression by listing your letters in alphabetical order. It's just kind of common practice, and then everybody knows the sequence when they're creating an expression or simplifying an expression. All right, so let's take a look at this next one. Again, in this one we have some x's and we have some y's. So we're going to try to collect any like terms here. So let's start with, we have an x squared. We're going to look along our expression, see if we have any other x squared terms. And we do have a 3x squared. And I hope you notice here, I'm also underlining the sign that's in front of it, because it's important to bring that plus or minus when you start moving things around. It will change your expression if you leave off a negative in particular. So make sure you always bring that plus or minus that's in front of a term with it. All right, so that's for my that's for my x squared terms. If I look at just my x terms, I have a plus 5x, but I don't have any other x terms as I look across my expression. So now I'm going to look, my y terms, I have a negative 3y here, and I have a negative 6y here. So those are going to get combined. And then finally I have my constants. I have a negative 4 and I have a positive 2. So I'm going to put my x squared first and then my x's. So we have a positive x squared plus 3x squared. And then my x's, I have just a positive 5x. And then from there we have our y. So we have a minus 3y, and we have a minus 6y. And then we have those constants to tack on. So we have a minus 4 and a plus 2. So now we can work on simplifying those. So the x squared and the plus 3x squared. Remember that that x squared has a coefficient of 1 in front of it. So we have a 1x squared plus 3x squared. So we'll get a 4x squared. Our 5x has nothing to simplify or combine with it, so it'll just stay 5x. And then we have a negative 3y minus 6y. So we're just going to really combine those coefficients. So a negative 3 minus 6 is a negative 9y. And then finally we have this positive 4 plus 2 here to combine. So positive 4 plus 2 is going to be a negative 2. All right, and you can see that my letters are in alphabetical order x, y, but when we start having exponents to our variables, we put those in descending order. So we'll get another example, we'll make sure to make note of that. So that's how we collect like terms. To build on that, we're going to talk about expanding and distributing into a set of into a set of brackets rather, and then continuing that process of simplifying by collecting like terms. So when we expand or when we distribute, we're basically taking any term that's outside a set of brackets and multiplying it by everything inside a bracket. So in our first expression here, we have 4 times 2x squared minus 3. So we're going to take that 4 and we're going to multiply it onto both of those terms. So we're going to have 4 times 2x squared. And then we're going to have, I'm going to put a plus here for now, we're going to have 4 times that negative 3. Okay, and then we're going to go ahead and actually do that multiplication out. So 4 times 2x squared is going to be 8x squared. And then we have 4 times a negative 3, so you're going to get a minus 12. Okay, we'll try with the next one as well. Keeping in mind, in this case, you always have to pay really close attention. They tend to sneak up on us, but we have this negative. So we have to remember how we multiply integers in terms of positives and negatives, and so we'll give that a try on this one. Okay, so we're going to take our negative 6x and we're going to multiply by every term inside this set of brackets. Okay, and you have to remember also about our exponents when we're adding. On the outside here we have a negative 6x to the power of 1. So when we distribute that in, we just have to make sure that we remember that rule for adding exponents. Okay, and on this negative 5x, we're going to have a power of 1. So a negative 6x times 4 is going to be a negative 24x. And then a negative 6x times a negative 5x, well, if we have a negative times a negative, hopefully remember a negative times a negative makes it a positive. 6 times 5 is 30. And then we have this x. So our rules for our integers that we would have done in grade 9 is if we have two powers with the same base, then we're going to add their exponents together. So we have x to the power of 1, x to the power of 1, so that's going to become x to the power of 2. And then finally we have a negative 6x times a positive 2x squared. So negative 6 times a positive 2 is going to be a negative 12x. And then again, we're going to add those exponents. So we have an exponent of 1 and an exponent of 2. So you're going to get an exponent of 3. Okay, moving right along, we're going to do a few more expand and simplify. And then we are going to make sure that we put them in the proper order that's kind of common practice. So I'll do the first one, and then I think I'll pause and have you guys try that second one. Okay, so the first one, we're going to expand this 3 into your brackets. And then we have a minus between, so we're going to take that minus 2 and we're going to expand it into that second set of brackets. So 3 times 4y is going to be 12y, and 3 times 2 is going to be a positive 6. Now again, on the second one, we have this minus 2, so we have to make sure that we take that minus into the brackets with us. So a negative 2 times 2y is going to be a negative 4y, and then we have a negative 2 times a negative 3, so we're going to have a plus 6. Now we have to take a look at simplifying by collecting our like terms. So we have a 12y and a negative 4y. Those are going to be like terms. And then we have no other letter part terms. We just have our constants here, plus 6 and plus 6. So 12 minus 4y is going to be an 8y. And then we have 6 plus 6, which is 12. Okay, go ahead and pause the video and see if you can try that second expression and see if you can expand and simplify it. Okay, so there's the solution for the second expression. Hopefully you got the same thing. One thing I just wanted to make note of, I had mentioned earlier on, that we always want to put our variables in alphabetical order, but when we start looking at our exponents, okay, and there's an exponent 1 here, we always want to list our terms with exponents in descending order. So we always put the largest exponents first in our equation and all the way down to the lowest exponent. All right. The last part of this note is talking about when we have an equation that has fractions in it. In order to make the equation easier to solve algebraically, we always want to try to clear those fractions and just make whole numbers because it makes the whole process a lot easier. So we're going to just try to simplify these and get rid of those fractions, but we are not going to solve, so do not solve. So we're going to multiply each equation by the appropriate amount to remove any fraction. So hopefully we remember, but to clear a fraction, we need to determine what's the lowest common denominator. Okay, so here we have a denominator of 2 and we have a denominator of 5. So the lowest common denominator between those, we could just multiply them together, hopefully you can see, is 10. Okay, so we are going to take, well, let me do that. We are going to take that common denominator and we're going to multiply each term by 10. So we're going to multiply this entire equation by 10. So we're going to have 3y times 10 minus x over 2, and we're going to multiply that by 10, and that's going to equal 1/5. And again, we're going to multiply that by 10 as well. Okay, so 10 times 3y is going to be 30y. And then if we have 10 and we have it over 2, we should be able to reduce those down to 5, right? So 10 over 2 is just 5. So sorry, that should be a minus sign. So we're going to have minus 5x. And then the same on the other side of your equals. We have 10 over 5. So that's going to reduce to 2. And you should just have equals 2. Okay, so we'll have 30y minus 5x equals 2. I'm going to pause the video again, see if you can give that second one a try. Okay, so there's the solution for that next example. So the lowest common denominator was 12, and when you multiply that through, hopefully you see that you can simplify the equation to 12y equals 9x plus 2. Okay. That's all for today, and we will move on to actually solving these algebraic equations tomorrow.